Go ahead.
All
Great.
right. So hello, everyone. My name is Yakubu Adamu. I'm a lecturer from IBB University, Niger State, Nigeria. I'm also a PhD student under supervision of Professor Charles Wang from the University of Aberdeen here in UK. And I'm here to present a paper titled Quantum Gravitational Wave Interaction with Large Sample Optical Superradiance. Basically, this paper is concerned with the theoretical investigation of gravitational quantum interaction with optical superradiance. And I believe some of us are actually familiar with superradiance. It's just a radiation enhancement effect that occurs when a group of excited atoms interact with a common light field. So in this paper, we numerically solved the derived master equation for gravitational wave, which allowed us to evaluate the dynamics of such interaction. Here is the contents, introduction objective, large sample optical superradiance gravitational master equation, then coupling to background aligned resonant classical gravitational wave. We have some numerical result and then discussion and conclusion. Now, like I've said earlier, the paper is actually concerned with results of theoretical investigation of gravitational wave interaction with large sample of optical superradiance. So what we did here is to introduce a new theoretical framework for calculating the total power and the energy of the spontaneous emission of photons by large sample superradiance. Then we studied the superradiant effect of coupling, and by constructing a gravitational master equation for a large sample of trapped atoms. And then we try to see from there the dynamics, the behavior of such a kind of interactions. Okay. So here, as an introduction, we know in quantum optics, superradiance is a phenomena that occurs when end emitters such as excited atom interact with a common light field. Superradiance, like we know, is actually theorized by Dirac in 1954. It's actually a collective quantum mechanical system where, where you have large samples of trapped atoms when they interact with a light field. So here is this place we have an example of a rotational superradiance, which is associated with the acceleration of motion of a body, which supply the energy and the momentum for the effect. This phenomenon is sometimes described as the consequences of effective field differential. Example could be the effect of tidal waves. Now, such effect allows the body with a concentration of angular or linear momentum to move towards a low energy state. Therefore, the rotation of this body in a particular medium will result in the transfer of both momentum and energy to the surrounding particle. And then by so doing, we are likely to dictate a particle or maybe discover a particle following trajectories that imply the removal of the momentum from the body. Okay. So here, as part of the purpose of this presentation is to show the result of theoretical investigation of the gravitational wave interaction with large sample superradiance to introduce a new theoretical framework for calculating both power and energy and the superradiant effect of coupling to background aligned resonance classical gravitational wave. Here we have an equation which defines large sample optical superradiance. So what we did here is to consider superradiant effect by using an n two-level atoms with state from the ground state to the excited state, or from the excited state to the ground state, which are taken as a time-independent interaction picture. So we actually used equation 6.9 of Gross, where we also obtain our master equation. Now, this master equation is an evolution. The evolution master equation is describe the general non-unitary statistical quantum evolution of the large sample superradiance. So as a result of this, the result of a dissipative effect with the environment, we are able to come up with this large, this equation. Now, this equation is the master equation that defines such interaction. However, it involves a tensor product matrix. So here too, we have the general master equation for the large sample of those trapped atoms. Now, in the interaction picture, we actually assume that the relativistic unit here for the speed of light should be equal to 1. So the general gravitational master equation for the matter that may be interacting and relativistic in nature was actually obtained using this using this equation. Now, this equation, the first time here is a conservative dynamics that is induced by the Hamiltonian interaction with itself and other field or other part of that are not actually part of the gravitational environment. And this is a density operator, which takes account in the interaction field. Also, this here is the non-Markovian dissipator. Yes. So by using this equation, we are able to derive the non-Markovian quantum dissipator, which is given by this equation. Now, this equation takes account the large samples of those trapped atom, which may be valid for time scale where short time transient memories are dumped away. So here we have the coupling to background aligned resonance cavity. So here we also consider harmonic gravitational wave that is actually traveling in z direction. The z direction here is actually the coordinate with a frequency which is defined by this time here, which is our omega here, which is also given by this equation. Now, if we apply the rotating wave approximation, we see that the corresponding interaction, Hamiltonian interaction, we have this very equation. Now, this very time here defines the radiation power, the gravitational radiation power. Also, the times here take cognizance of the frequency domain for the reduced quadrupole moment, and this time also defines the transition from probably the exact state to the, from the ground state to the exact state. Now, if we neglect the self-gravity, then the value of the self-Hamiltonian is actually the Hamiltonian coupling for the classical gravitational wave. Now we have the propagation effect in superradiant sample. Now, the coupling Hamiltonian and the operators here play the role of the system of interest. This suggests a possibility of simulating the dynamical effect of gravitational wave with large sample superradiance. Now, this figure, the two figures here, actually correspond to the emission of photon by atom J and atom I. Now, those are the sample trapped atoms. Now, the condition expresses the fact that the photon is propagating from left to the right in the sample. It is worth noticing that this propagation effect directly comes from the real and the imaginary dissipative times. So for the imaginary time, it is actually the contribution of quasi-resonance processes with the K, that is the wave number, obeying conditions which are essential in the propagation effect in the superradiant samples. And here we also have the gravitational radiation power and the dissipative gravitational emission power. Now, the two figures also are the result of the dynamics of the gravitational wave radiation power and the dissipative emission power. This accounted for the Hamiltonian and the dissipative effect. The observed dissipative signals actually is the effect of fluctuation that could be derived by different coherence channels and the internal trap dynamics of the atom, which could amount to reducing the spontaneous emission over this given time, which is the rate here. Yes. So the N here actually defines the number of atoms, and the N naught here is actually the wave number. The L here defines the lattice length. So only the photons emitted in the diffraction angle of this sample are useful to start the superradiant effect. Now we have the energy, the system energy and the gravitational wave net power. So the two figure actually is also a plot of the time-dependent rate associated with the atom systems and the net power. The rate induces a decreasing behavior in the coherence, which are also as a result of damp oscillations of the rate. So the consequence, which is also a consequence, sorry, of the strong interaction with the localized frequency mode. The oscillation observed here as a result of the interaction of the coupling region of the system. So to end it, this is just a brief discussion of what we actually have, which cannot be presented here due to some time constraint. But to cap it all, the gravitational master equation is actually due to the passive self-gravity of matter and retains the unitary quantum nature. Therefore, it is non-unitary. It has a non-unitary characteristics and hence induce a decoherence and dissipation, as we can observe in the plots. So the propagation effect in the superradiant sample, that is in figure 4 and 5, correspond to the emission of the photons by the trapped atoms. These are observed to come from the imaginary dissipative times as described in the equation for optical superradiance. Now, the dissipative behavior or signal could be the consequence of coherence losses introduced in the microbial master equation, which can be recognized as the effect of the exponential decoherence factor. Also, the dissipative behavior observed in the figure 7 and 8 could also be a consequence of the coherence losses, which occurs when the geometric factor is proportional to the diffraction of the solid angle of the pencil-shaped volume, which in turn reduce the spontaneous emission. The present formalism is actually applicable for general Bosmic field, since their gravitational interaction do not involve derivatives of the matrix. So it has no matrix signature. In conclusion, or in summary, we have actually demonstrated the possibility of gravitational wave interaction.
2 more minutes, Dr. Adamu.
All right, thank you. So formulating a gravitational master equation has actually been a subject of some substantial investigation. So the derived equation, which is actually based on Hamiltonian field interaction, we've incorporated both the vacuum and the thermal fluctuation in principle, which can be applied to relativistic domain. However, the gravitational field considered here are gauge fixed and account only for the graviton effect. So the versatility of this equation allowed us to probe a range of gravitational fluctuation scenario, including those due to superradiant and fluctuations. Thank you so much.